Imagine a world where cars run on a fuel that emits nothing but water vapor. Where long road trips require no stops at gas stations and where transportation is powered by the most abundant element in the universe. This may sound like a futuristic dream, but it's closer to reality than you may think. With advancements in technology, hydrogen engines are emerging as a promising alternative to electric vehicles, EVs. While EVs have dominated the conversation around sustainable transportation in recent years, hydrogen-powered engines offer their own unique advantages that could revolutionize the way we travel. In this video, we'll explore how the new hydrogen engines can potentially replace the EV industry and the benefits that come with this exciting development. Let's quickly get started. As the world searches for cleaner and more efficient transportation, hydrogen vehicles have emerged as a promising option. These vehicles come in different forms, with the most common being those that use fuel cells. In this technology, hydrogen reacts with oxygen in a fuel cell to produce water vapor and electrical energy. This energy powers the electric motor that drives the vehicle. Hydrogen engines, on the other hand, are designed to optimize the combustion of a hydrogen-air mixture to generate power. However, this concept has not yet gained widespread adoption due to safety concerns. Fuel cell technology, known as FCEVs, is the most common type of hydrogen vehicle on the market. FCEVs work similarly to traditional electric vehicles but draw their power from fuel cells rather than external charging sources. These fuel cells consist of two chambers separated by a rare earth metal-coated membrane, which acts as a catalyst to facilitate the hydrolysis reaction between hydrogen and oxygen. This reaction produces water vapor and free electrons that enter the car's electrical network to provide power. Renault is leading the charge with its upcoming releases of two hydrogen-powered utility vehicles, the Kangoo ZE Hydrogen and the Master ZE Hydrogen. These vehicles use a different method of energy storage compared to the majority of electric cars that rely on lithium-ion batteries. Instead, they use hydrogen fuel cells to generate electricity from the gas produced by the decomposition of water or methane. The process is simple yet revolutionary. Within the fuel cell, the hydrogen gas is converted into electricity through a chemical reaction with the oxygen present in the surrounding air. This means that the only byproduct of the process is water, making hydrogen-powered electric cars completely emissions-free. But how does it work in practice? Hydrogen fuel cells are fed by a tank that contains the gas stored at a very high pressure of several hundred bars. You can now say goodbye to long hours spent waiting for your car to charge up at a charging station. With hydrogen engines, you can refuel your car in just a few minutes, making it a game changer in the world of eco-friendly transportation. Not only do hydrogen engines have a higher energy density and longer driving ranges, but they also produce zero emissions, running on renewable energy sources like solar and wind power. Not only are hydrogen engines practical and eco-friendly, but they're also incredibly versatile. They can be used in everything from cars and buses to trucks, boats, and even airplanes. With such a wide range of applications, hydrogen engines offer unparalleled flexibility in the world of sustainable transportation. The potential for mass adoption of hydrogen engines is also exciting. With the ability to be mass-produced like traditional gasoline engines, hydrogen engines could become more affordable and accessible to consumers in the near future. Did you know that hydrogen cars have been around since 1966? Although they haven't always been successful, Toyota is changing that with their cutting-edge hydrogen-powered vehicles. These cars are not only more efficient than traditional combustion engines, but Toyota is also developing fuel cells for commercial use, which could be a game changer for the transportation industry. Toyota has just unveiled a brand new addition to their lineup, and it runs on hydrogen fuel cell technology. While the company's new CEO plans to expand its battery electric vehicles, Toyota is not abandoning its commitment to FCEVs. This autumn, they'll be launching a new 5-seater sedan, the FCEV version of the Toyota Crown. This marks the first new hydrogen car from Toyota in almost a decade, since the introduction of their flagship FCEV, the Mirai, in 2014. But Toyota isn't stopping there. They're also releasing a hybrid electric version of the Crown, as well as hybrid and plug-in electric estate and sports versions. While Toyota's focus on hydrogen cars over the past decade has left them behind on battery EVs, they're still making moves towards a more sustainable future. And with only 2 FCEVs currently on the market, the new Toyota Crown FCEV is a welcome addition to the eco-friendly car world. Plus, with over 10 million BEVs and plug-in hybrid EVs delivered worldwide in 2022 alone, it's clear that sustainable transportation is here to stay. However, the company may be shifting its focus from passenger vehicles to heavy-duty trucking. According to Hiroki Nakajima, Toyota's chief technology officer, one of the advantages of fuel cell vehicles is that they are lightweight and require less space for energy storage. Plus, refueling takes only a few minutes. With these benefits in mind, Toyota plans to promote the use of fuel cell vehicles in commercial settings, starting with medium to heavy-duty trucks. In fact, the company has already begun basic research on hydrogen engines for these types of vehicles. So while Toyota's hydrogen future may look different than initially expected, it's clear that the company is still committed to finding innovative and sustainable solutions for the transportation industry. Moreover, hydrogen cars have the potential to travel further on a single tank of fuel than electric vehicles can on a single charge. And with the right partnerships between governments, fuel providers, and car manufacturers, a robust infrastructure for hydrogen fueling could become a reality. And when it comes to maintaining a vehicle, less is definitely more. With fewer moving parts than traditional gasoline engines, these engines require less maintenance overall. This translates to lower maintenance costs for both consumers and businesses, making hydrogen engines a practical and cost-effective option for sustainable transportation. And for businesses that rely on transportation, lower maintenance costs can translate to higher profits and better efficiency overall. While hydrogen-powered electric cars offer a promising solution to our transportation woes, there are still some hurdles to overcome before they can take over the roads. One of the major obstacles lies in the manufacturing process of the fuel cells that power these vehicles. Fuel cells require rare metals and an energy source, which may not always be renewable to produce. This means that the production process itself can pose a challenge to achieving true sustainability. Furthermore, large-scale adoption of hydrogen-powered electric cars would require significant infrastructure development for the production and distribution of hydrogen. The automobile industry is in a state of flux, with competing technologies vying for supremacy in the race to zero emissions. While most manufacturers have thrown their weight behind battery electric vehicles, BEVs, a handful of industry leaders remain steadfast in their commitment to hydrogen fuel cell technology. Toyota, Hyundai, and General Motors are among the automotive giants that have continued to invest in the development of hydrogen fuel cell powertrains, despite the challenges they face. While fuel cell electric vehicles have the potential to achieve zero-emission travel, they are currently less efficient than BEVs and have struggled to gain widespread acceptance among consumers. One of the major walls to the adoption of fuel cell electric vehicles is the lack of infrastructure. Unlike BEVs, which can be charged overnight in the comfort of one's own home, hydrogen fuel cell vehicles require specialized refueling stations that are not yet widely available. Even in the commercial truck market, where fuel cell electric vehicles may have had a chance to succeed, recent research has cast doubt on their viability. Despite these challenges, however, some manufacturers remain committed to the development of this promising technology, holding out hope for a future in which hydrogen fuel cell vehicles can play a significant role in the quest for sustainable transportation. With that, we hope you enjoyed learning about the potential of hydrogen engines to transform the transportation industry. What do you think about this technology? Do you believe it could eventually replace electric vehicles? Let us know in the comments below. And don't forget to like, share and subscribe.